Find the highest common factor, HCF, of 72 and 90. I'm going to show you several ways to do this, okay? It's only a 2-mark question, but I want to give you lots of different options, okay? Because there are lots of different ways you can work this out. So probably the most simple way of doing this, list the factors, okay? So I'm going to put 72 here, and I'm going to list the factors. So remember the word factor. Factor means there's something that divides into the number exactly with no remainder. So 1 divides into 72, clearly, with no remainder, and it does so 72 times. 2 divides into 72, exactly, 36 times. 3 divides into 72, exactly. And how do I know that off the top of my head? Well, because 7 plus 2 makes 9, and 9 is divisible by 3, so that's a little trick to work out whether 3 is a factor if you add together the digits of the number. So 7 plus 2 gives you 9, and if that is in the 3 times table, then 3 goes into the number. And I'm just going to do a quick calculation to work out how many 3's are in 72. Well, 3's into 7 goes twice, remainder 1. And then 3's into 12 go 4. So 3 divides in 24 times to give you 72. 4 goes in as well. We'll do a little calculation for that. Let's have a look. So 4's into 72. 4's into 7 goes once, remainder 3. And then 4's into 32, 8. So 18. So 4 goes in 18 times to give 72. 5 doesn't go in because it doesn't end in a 0 or a 5. 6, well, hopefully you know your 12 and 6 times table, so 6 12s is 72. 7 doesn't go in. Can you see what I'm doing here as well? I'm just literally going up in order. So 1, 2, 3, 4. I knew that 5 didn't go in. 6. And basically you go until you can't go any further. So 7's not going to be an option there. 8, 9 8s is 72 because of my times tables. And then, we've gone full circle. Okay, so once you kind of loop back round, which you will do, you don't need to do this one because we've already got it. Okay, so we've already got that one. Then you know that you are done. Okay, so they're all the factors. So 1, 72, 2, 36, 3, 24. These are all the factors. Gosh, it's got lots of them, isn't it? Of 72. Let's do the same for 90. So 1 multiplied by 90 is 90. 2 multiplied by, hopefully you can just halve 90 in your head to get 45. 3 goes in, because obviously 3 goes into 9, so 3 lots of 30 give you 90. 4, well, if you don't know, let's just do a little check. Does 4 go in? 4 goes into 9. Does 4 go into 90? 4's into 9 goes twice, remainder 1. And then 4 doesn't go into 10, so no, that doesn't go in. 5 goes in, clearly, because 90 ends in a 0. And if you think about it, there are 20 5s in 100, and 90 is 2 5s less than 100, so it must be 18. 6, does 6 go in? Yes, it does. 15 times. 7 doesn't go in. 8 doesn't go in. 9 clearly. And then 10, look, we've gone full circle again. So we don't need to do that one. So I know that might seem a bit long-winded, that much time, if you use the same method. So again, I have just gone up in order, so you know that you don't miss out any factors. As long as you go up in this sort of order, you won't miss out any factors. And then the question is, what's the highest common factor? So we're looking for the biggest number that is in both factor lists. Well, the biggest number that is in both factor lists is 18. Okay, 18 is the biggest number in both lists. Another way that you can do this is to sort of eliminate factors at the same time. It's kind of the best way I can explain it. So write down 72 and 90 in like a table. And you're finding a factor that goes into the two of them, okay? So they're both even numbers. So I know that 2 goes into the two of them. And 2 goes into 72 36 times and 45 times. And now you're looking for another factor that goes into these two numbers respectively. And a number that I know goes into those two is 3. So 3 goes into 36 12 times. 3 goes into 45. So I know the temptation is to go back to this number, but we're actually looking at this number now. So 3 goes into 45 15 times. And then I can see that another common factor of these two numbers is 3. So I'm going to take out 3 as a factor again and get 4 here and 5 here respectively. And it's when you get to this point on the table where you don't have a common factor between these two numbers any further. So you stop at this point because there are no common factors. So here we had a common factor, here we had a common factor of here we had a common factor of 2, then we had a common factor of 3, then we had another common factor of 3. Okay, but here we don't have any, there's no common factor between 4 and 5. Okay, so we stop at this point. And then what you've got here is, if you multiply these, you get your highest common factor. So if you multiply these, you get your highest common factor. So 2 times 3 times 3, which is 18. So again, the pen wasn't working there for a second. 2 times 3 times 3 is 18, and you get your highest common factor that way. The final way I'm going to show you to find the highest common factor of two numbers is to use product of prime factors, or factor trees as you might have seen it, and also then using a Venn diagram. So this is a little bit long-winded for a two-mark question, but I just thought I'd show you it because it could be the way that you have been taught to do this. So the first thing you're going to do is work out the factor tree for 72 and the factor tree for 90. So, and you split it like this. Hopefully you recognise this. So you're finding two numbers here that multiply to give 72. So I'm going to go for 9 times 8 because I know that from my times tables. And then you keep going until you get a prime number. So two numbers that multiply to give 9 are 3 and 3, and they are both prime. And when you get to a prime number, you put a circle around it. Maybe you have seen this before, hopefully you have. What two numbers multiply to give 8? 4 multiplied by 2. And then when you get a prime number, you circle it. Two numbers that multiply to give 4 are 2 times 2. And they are both prime. So as a product of its prime factors, 72 is 3 times 3 times 2 times 2 times 2. Let's do the same for 90. Two numbers that multiply to give 90 are 9 and 10. Neither of those are prime, so keep going. 9 is 3 times prime. There's a circle around it. 10 is 5 times 2, and they're both prime. So as a product of prime factors for 90, it would be 3 times 3 times 5 times 2. And then what we do now is you do a Venn diagram. So maybe you have been taught this. And this circle I'm going to say refers to the 90, and this circle I'm going to say refers to the 72. And we are interested in the overlap, okay, the overlap here, this space here. Why? Because we want the highest common factor. Okay, what is the common factor for both of them? Well, okay, let's have a look at what is in the overlap. So I can see a 3 here and 3 here. So I put a single 3 in the overlap, a single 3. It's really important that you don't do 2 3s, okay, because they are common to both factor trees. So I put 1 in the overlap. I can see another 3, this one and this one. So I put 1 in the overlap. I can see a 2 on both trees. Doesn't matter which one you cross off. So I'm going to put 1 in the overlap. Is there anything else that is common on both trees? No. I've got 2 2s, so I'm going to put a 2 there and a 2 there. And then there's this little 5 that is just applies to the 90 and not the 72. And it's this overlap which, if you multiply them, gives you your highest common factor. So if you multiply them, this is where some students go wrong because they might add them, but don't add them, you multiply them. And again, we're going to get our value 18. If you are asked for the lowest common multiple, just as a little side thing here, if you are asked for the lowest common multiple, you multiply them all, okay? So all of them, every single one of them, that would be your lowest common multiple. You multiply them all, okay? But the highest common factor is just the overlap, the blue section for this question.